NaniCodes. I hope you all doing well. Okay, let's do today's daily Leetcode challenge question. Construct binary tree from preorder and inorder traversal. Let's read the question briefly. Okay, given two integer arrays, preorder and inorder have been given. Where preorder is a preorder traversal of binary tree, preorder represents a preorder traversal of a binary tree, and inorder represents a inorder traversal of a binary tree. Okay. We need to construct and return a binary tree using these preorder and inorder arrays. Note that we will get a unique binary tree always when we construct a binary tree using preorder and inorder. Okay, let's understand and let's decode the question using a algorithm. Okay friends, let's discuss the logic behind the question. Here we need to find the first element of preorder array. The first element will be 10. This should be selected as root always. We need to find the index of 10, the index value of 10 in inorder array. All the elements which are at left to the 10 will be selected as left subtree, and all the elements which are right to the 10 will be selected as right subtree. So now we can see from the example. Here 10 is a root and all the elements 40, 20 and 50 are present at left to the 10, and all the elements 60 and 30 are present at right subtree of 10. So now we will call recursive function again for 40, 20 and 50 and 60, 30 and 40. From 40, 20 and 50 we will get one preorder subtree and one inorder subtree. The preorder subtree will be selected from preorder array as 20, 40, 50. These contiguous elements will be selected as preorder subtree, and the inorder subtree will be selected from inorder tree as 40, 20 and 50. 40, 20, 50 contiguous elements are selected as inorder subtree, and same with preorder subtree also. From right preorder subtree we will select preorders as 30 and 60. 30 and 60 will be our preorder subtree, which is from preorder array, and 60 and 30 are inorder right subtree, which from inorder array. So we will call recursive function again for these. For first left subtree and second for right subtree. The first recursive call 20, 40 and 50. We need to select 20 as root element, as 20 is the first element of preorder subtree. We need to find the index of 20 in inorder subtree. Here the index of 20 in inorder subtree is 1. So the elements which are at left to the 20 are left subtree of 20, and the elements which are right to the 20 are right subtree of 20. So the elements are arranged as 20 and 40 and 50. Now we will call another recursive function for 40. Here 40 is a leaf node, so there are no values at left child and right child. There will be a null values, so we will return to right subtree of 20. So we will come to 50. As 50 is also a root node, there are no childs for 50. That means null. It will be null. So we need to come back to right subtree of 10. Here the right subtree of 10 contains values 30 and 60. From preorder subtree, we need to take the first element as root element. It is a 30. 30 will be taken as root element. Now there are no right elements. There are no right elements to 30. So we will declare it as null, and only the 60 is present at left. So 60 will be in left subtree. Now we will call recursive function again for 60. For 60, as it is a leaf node, there are no values. I mean there is a null value. So we will come back to 30 and we'll come back to right subtree of 30. There is no values again, so we need to print. We need to return the values using the recursive function. The binary tree, the resultant binary tree will be as follows. First, the resultant binary tree will be as one second. The resultant binary tree will be as 10, 20 and 40. We need to come in this manner: 10, 20, 40, again 20 and 50, again 20, 10, 30, 60, again 30, and there is no value here, it's null value. We need to return the null value also, and we come back and we'll come back to root again. The root elements, okay, 40, 10, 20, 40, 50, and after 50 we'll come back to the right subtree of 10 and we'll print 30, and we'll go to left subtree of 30. We'll return 60, and after 60 we will go to 30 and and for next recursive call we'll return null, as there is no right subtree for 30, and the resultant output will be as follows: 10, 20, 40, 50, 30, 60 and null. Using this inorder array and preorder array, the resultant binary tree will be as follows. Okay, let's now start coding part. First, we declare a hash map. In hash map, we store data as key value pairs. Hash map is also used to delete the duplicate values. We will insert the hash map. We will insert the elements of the hash map using this for loop. All the elements are stored as key value pairs here. Now we will declare a recursive function as build tree. In the recursive function, first we need to check the condition whether pre-start is greater than pre-end or in-start is greater than in-end. If the condition is true, we will directly return null. Here pre-start and in-start are the first elements of preorder and inorder, and pre-end and in-end are the first and the last elements of preorder and inorder. Now we need to declare one more variable, root. Here root stores the first element of preorder. Preset is the first element. That element will be stored in the root. Now we need to check. Now we need to get the index value of root element. This root element index value will be stored in root. Now we will declare another variable numsleft, which gives the difference between in root, which gives the difference between in root and in start. Now we will make another recursive function for left subtree, and we will make another recursive function for right subtree. We need to check the condition until or unless we'll get a null value. If we get a null value in right subtree, we'll directly return the root. And if we get a null value in right subtree, we'll directly return to the root. And the given example will give the binary tree value as 3, 9, 20, null, 15, 7 from the given preorder and inorder values. Thank you.